Right, so I'm going to show what I have right now, which is basically a distributed ROS2 setup. So we have uh, two machines, I guess, on our ROS2 setup, which are connected with Ethernet cables on an Ethernet router. In the first one, it's the Qualcomm board, which is running the Qualcomm Intelligent Robotics, which is essentially ROS2 Jazzy distribution. And on the workstation, I have a robotics Docker running, which is essentially the same distribution of ROS2, Jazzy, but this time it's just the standard install. And so let me switch to computer. So this is the workstation. This one is running the Docker, the robotics Docker here. And this will be connected to the Qualcomm. I just need to SSH root that and do that. Linux 123. All right, so set grab class. All right, I have to initialize the setup scripts. Okay, so we can see we have ROS2 Jazzy running here, and on the robotics Docker, set ROS, the same versions. So here we can see it's the version 1.4 of the Qualcomm Intelligent Robotics product or package. So here on the workstation on the right, there's a bunch of tools that we can use for visualization. So RQT, wait a sec, let me launch that. Background, so we'll be using that later on. We also have RQT graph that we use to see what nodes are running. So I will launch just to show the ROS2 packages executables. Qualcomm has a bunch of custom nodes, which are all QRB, and one of them was to run QRB ROS system monitor. QRB. So that's the package name. Then we need to put the node name. ROS. In this case, it's the same. So that'll run a ROS node, which is publishing system resources. So CPU monitor, memory monitor, temperature, disk, spot, battery, system info. So here on the other computer, we can actually see these topics being published. And we can also ROS2 topic list, ROS2 topic code, temperature maybe. Register. Okay, so it's publishing at every few seconds. It looks like 37 degrees. So this just shows that our two ROS entities are able to communicate with each other. So let me put this down so we can see that the topics have disappeared, the nodes and the topics have disappeared. Now, if I launch, let me get back to the slides. So now if we have our now this time with the Qualcomm, I'll run two ROS nodes, which will be capturing images from a USB camera plugged on the USB port, publishing that as image raw, and then our ASL controller, which will be looking at the image, finding the hands, recognizing the hand signs, so the letters, sign language, and I'm publishing an annotated image showing the results here. And then I'll be publishing these post-stamp messages, which are basically the joint directories for the ARM controller and the gripper controller of a simple robotic arm that's running on the other PC in Gazebo. So let me launch that so you can see what it looks like. So if we start with the system on the left, ROS2 launch ASL, yeah, this is my ROS2 package. ASL confirm USB pen, ASL controller joints, Pi. So you see there's nothing being displayed. I don't have the display working on the Qualcomm board right now. And remote X Windows is not working either, but it's publishing messages. So we can, in the same way that we saw the topics previously, you can see that here as well. So you can see we have our input image, ARM controller, joint trajectory, and gripper controller, joint trajectory, and our annotated image. We can look at it here as well. So this is basically, I don't know why it doesn't show the output, probably because it's not communicating with anyone, so it's only showing what's active. Oops, I lifted my hand and we got a bit of action here. But now here, let me launch the actual, the right side of the ROS2 demo, which is running on the Robotics Doctor. Launch. Let me to simple arm. File completion works on the Robotics Doctor, which is convenient. Spawn robot. Ah, shouldn't have. We can actually launch it without RViz. So I'll have the. So this is the actual simulation environment. So we have a robotic arm with a bunch of objects on a table. And the idea is that we're going to try to control this robotic arm with our hand signs. So if we refresh what's happening, we can see there's additional content now. So additional nodes, additional topics. So we can see here in the gazebo, there's actually the states of the robot and the transforms of the joints of the robot that are being published. On our side, we have my camera, which is the USB camera publisher. Then we have the ASL controller. So from the sign language, we're publishing joint trajectories for the arm and the gripper. So the arm will be done with the left hand, the gripper will be done with the right hand. And this communicates with these two nodes, which are running on the robotics docker. So this graph is a little confusing because we don't see what's running on which machine. I don't know if there's a way to do that. We'll see. So I'll just. And we can also see images. So visualization in the RQT, we can put. Oh, it automatically found. So this is me, the live image. Then we have the annotated image, which you can see is probably, I'm guessing 5-6 frames per second, so it's a little slow. Our MediaPipe model is not running real time. Let me add another one. Because we have, there's also a camera on the gripper. So here, the gripper is a camera facing upwards right now because that's why we have a gray image here. But as we bring the arm down, we'll start seeing objects in the Gazebo simulation. So, all right. So what happens is this RQT viewer sometimes freezes. Like you can see, it's frozen here right now. Well, yeah, it's frozen, but the commands are still being sent, so that makes it a little confusing. But here we go. So just to show, I could open the gripper with the doing a B on the right hand, or close it with the right hand, right hand, that's right. So you can see the annotated image is the mirror of the original image. That's because this is what we're going to want to show to the user, because a flipped image becomes confusing for controlling. So that's why the ASL controller, the hand controller, is working with the mirrored image. So let me open that gripper. Whoops, open hand. So you can see these images were not updated, but the command still went through. I don't know if there's a way to add priority for these image topics. It's not over the wireless, it's over Ethernet cables. I don't know why it's, see there's a little lag also between the two. That's because of the latency going through the media pipe model. So I'm going to try to pick up this red object in front of me. So the way that I have set up the controls is the left and right will turn this shoulder joint. So that's F, L, and R hand signs. The left and up and down will control this shoulder joint. No, front and back will control this one, and up and down will control this one. And I'm not doing anything with this joint. So I just moved, okay, mapped certain of the joints to some hand signs. All right, so let me just lower using the down. So this is the hand sign for down. See, bring the arm down, and you'll start to see here the gripper camera will start to see the table at some point as the arm gets lower enough. So this camera on the gripper helps to actually catch the objects, because just looking at the simulation becomes a little confusing for me anyway. I'm not used to gaming anymore. So. All right. So the way these joints are done, so I've lowered this one, but now I want to turn this one, which will advance the arm, but it'll also lower it because this is, anyway, has this angle. So I'll just keep adjusting that. Oops, I accidentally closed the gripper. You have to watch what you're doing with your hands. So advance. So that's like a fist. Too bad I'm not seeing it in the image views. Advance. I'd go up a bit so I could advance more. A bit. Advance more. And now I'll close the gripper. And I think I have the object. Now I'll raise the arm. And I've picked up the object. So that's essentially what's going on. We have our demo. Our hand controller is running at 5.6 frames per second. We may want to accelerate that. And if I open the gripper, the object's going to fall on the table. So, boom. Et voila. That's where we're at right now.